Okay, so this is kind of exciting. We're getting through all these free response topics, and I see you guys are checking your answers to the 2003 multiple choice section. And if you want, we can jump right to. I can't spend a lot of time going over too many of them. That's why I do have the videos available. But I'd like maybe you guys want to go over a couple right away. We can also do them in review, but well, no. Why don't we just go over a couple right now? Yes. Number 9, and then I'll get to this fill-in. We'll just change things up a little bit. Okay, number 9. So they asked you for the derivative at 0. So you have to know that the derivative of the ln of u is u prime over u. So, first you always write the derivative, write the rule, then you plug in the number. So check if you got the u prime right. U prime would be 1, because the derivative of x is 1, and the derivative of e to the negative 3x is e to the negative 3x times negative 3. Okay, but are you okay with, the derivative of the ln of u is u prime over u? Okay, so you take the derivative, the ln of the whole thing here is your u, that goes on the bottom, and its derivative goes up top. Once you write down the derivative, then you just plug in 0 for all the x's. Yes? Yeah, I don't have those on it. I didn't want another sheet for that. So we said 27 was d 1/4, and 28 is e. b 1/4, and 28 I think is e. And I'll give, yes, sure. Other questions? Yeah. Because you're taking the derivative of the u. So the derivative of x is 1. The derivative of 4 would be plus 0. And the derivative of e to the negative x is e to the negative x times negative 3. Okay? Yep, it's got to be u prime over u for the derivative of the ln of u. Let me take a few more questions, guys. Yes, 18. I love these. They're so fun. Ooh, what? Oops. Oh, it's a table. Woo. Okay. Let's see. They tell us that g prime is continuous and is exactly 2 zeros. So we don't have to worry about it going to 0 someplace else. And they want to know where g is decreasing. I bet you said from -1 to 1. Is that what you said? See, what you have to remember is you have a whole bunch of points. Like, so obviously you knew the big thing, that a function's decreasing when the derivative is negative. But what about -1.5? -1.7? You can't just think about integers when you think about numbers. If you think about, so you know that the derivative is 0 here at -2, and you know the derivative is 0 at 2. And everywhere in between, it's going to be negative because they told you it can't go back up to 0. So you can't forget about numbers like 1.7. It's still going to be negative there. So you really want to go from 0, where it's 0, to where it's 0. Do you get that? Okay. Other little questions? Yes. 28. Don't even tell me I don't have 28. How funny would that be? Oh, this might be the one question I can't put on. 27? I think I might have put that on my other one. Alright, well, an inverse of a function is what you get when you switch all the x's and y's, okay? And the derivative of an inverse is related to the derivative of a function. They're just reciprocals. The only thing is they're not just reciprocal values at the same x. They're at different x values. So to take the derivative, and this is the little formula, When they ask you to find, let's say, okay, in this one they said, what is the derivative of the inverse of f, which they call g, at 2? It's going to be 1 over f prime of a different number, okay? But realize it's the reciprocal of the derivative of the function. Now, you have to figure out what number do you plug into the derivative of the original function. And all that comes from the fact that when you have a function and its inverse, the slopes will be reciprocals, but if the slope over here at AB will be the reciprocal of the slope over here at BA. Okay, so at different x values. So in this problem, they said, okay, what's the slope of the inverse at 2? Let's say that this is the inverse and this is the function. You've got to figure out, first of all, what's the x-coordinate on the original function. The way you get it is you just, if they want the derivative of the inverse of 2, realize that would be the y-coordinate on the function. So figure out its x-coordinate. So in this case, let me see what they told us. So if y is 2 on the function, let's solve for x. If you put in 2 for y, okay, and solve for x. Now, usually these on the AP exam, they're just numbers you just think of, okay? So if you put in 2 here, 2 equals x cubed plus x. You don't have a calculator. You just think of numbers like 0, 1, 2. Can you see what number would be? 1. So the slope of the inverse at 2 is 1 over the slope of the function at 1. Because this point over here is 1, 2. So, oh, they told us that? Yeah. So you have to know that, yeah, you're just going to figure out the derivative of the function, but not at the same x value, okay? It's got to be, that's the y value in the function, so figure out the x for the function, plug that number into, so we figured out it's 1, plug that number into the derivative, and take the reciprocal. So it'll be, the slope over here will be 1 over the derivative of the original function at 1. So that's what we had to do here. So you plug 1 into the derivative, you get 4. So the slope over here will be 1/4. Right? When you figure out that the derivative of the original function is 4, by plugging 1 into the function, the derivative of the function, we've switched all the x's and y's to get the inverses. So over here, the slope would have to be 1/4. That's what they want. So just remember, it's 1 over the derivative of the original function, but not at the same x value. You have to figure out the x. What they basically given you, when they give you the x for the inverse, is the y for the function. So get the x, pop it into the derivative, and flip it. Yeah. I know that one's annoying. Want to do one more, or you want to get to rates? Let's get to rates. Let's do rates. Because you can see these little video examples. Oh, I'm sorry, I didn't have that one up there. But okay, well, rate problems on the AP exam, the good news is that they tend to be calculator question. And the rate problems, they're word problems. They either involve one rate, which I'll call for today's, we'll do now RFT, or 2 rates, a rate in and a rate out. But something's changing. And the way you know that a word problem is really a rate problem, well, something will be changing. And what else would you notice about, they won't say something's a derivative. They'll just say, oh, let this be the rate at which something's changing. What are you going to notice about its units? Something over something. So one of the big clues that you have when you're going to do a word problem that it's a rate problem is that they're going to give you functions, but the units are going to look like ratios. They will be rates. So the unit will be a ratio. It might be feet per second. It might be people per square mile. It's something over something else. Now, again, these problems will involve either one rate or two rates, rate in and a rate out. If the problem just involves one rate, R of t, and they ask you to find the rate at a particular time, A, what would you do? So they give you some function R of t, which is the rate at which something's changing. They want to know the rate at which it's changing when t equals 5 or t equals 7. Yeah, when you say evaluate it, what are you going to do? Plug it in, right? So it would just be, we just plug it into your rate function, so it'd be R of A. Now we'll see if you remember this one. What if it's a rate in, rate out problem? Rate in E of t, rate out L of t. And they want you to find the rate of change at a particular time, t equals A. Yeah. E of rate in at A minus rate out at A. That's all. They're just looking for the rate. You don't have to do anything to it. If they just want to know how fast is the quantity changing at a particular time, just plug the time in. You just have to know that, you have to do rate in minus rate out there. Now, I threw this one in here. Not that it's a typical question. I have seen it, though. So you have either the one rate or the two rates, and they ask you to find the maximum value of the rate. How do you find the maximum value of anything over a closed interval? Yes, Gina? Yes. So you have to figure out that rate or rates. It's either one of it's depending upon whether you just have the one rate or the rate in minus rate out. Did I just spell that out? Nope. You'll have to figure out those rates at the endpoints at A and B. And you said it, but I just want to get that again. If you're looking for the maximum rate, you'd have to get the rate at the endpoints. Where else? Where it goes from positive to negative. So you'd have to find out where, in this case, R of t goes from positive to negative. Let's say that value is C. Or in this case, where rate in minus rate out goes from positive to negative. And then you could evaluate the rate, plug those numbers in, and compare them. Now, because these problems are usually on the calculator, if you had to see where the given rate is going from positive to negative, what's the easiest way to do that? They've given you the rate. Yes, Gina? Graph it. And you just look to see where that graph is going from positive to negative. Right, you get the 0. Or in this case, graph rate in minus rate out. We like to put that in Y3. And again, see where it's going from positive to negative. The easiest way. Okay, what do we do to get the units of a definite integral? What do we do? Like if we have the definite integral of some function. What do we do with the units of f of x and the units of x? We multiply them. Multiply the units of f of x by the units, and dx will be the same units as x. To have the same units as x, units of x. Nice. So you have to know to multiply. Sometimes they ask for units. If they give you the derivative, because that's what the rate is, and they ask you to find the total change. So suppose they give you some rate that stands for rhinoceroses per hour. All right? And they ask you for the total change in the number of rhinoceroses, I'm not to pluralize that, over from time A to time B, or whatever. What do you do to get the total change in any function? So f prime of x, like this is like your rate. What do you do to that rate to get the change in the function? Integrate it. Now, if I want to get the total change in the function, what should my lower and upper limits be if I want to get the total change of A to B, right? Because if you take the antiderivative of f prime, you get f of x, and you plug in the b and the a and subtract. So you would integrate it. And I'll give you f of b minus f of a. Integrated rate of change. You get the change in the function. Okay, this one you've seen over and over, but I'm just going to keep hitting you with this one. Suppose they give you f of a and they give you the derivative of the function, which will be your r of t or your e of t minus l of t. How do you find the value of f of b? F of a of f prime of x. Good. Seen that a lot, right? And I think this is the last one here. You bet. If you want to find, so let's say you have the rate of change, either rate in minus rate out or just the one rate of change of some quantity. I don't know what it is, okay? But you want to find the maximum value of that function, okay? And these are the rates of change of the function. What should we call it? Maximum value of a function. I didn't give it a name. We'll just call it f of t. Okay, but we are either given the rate at which it's changing, r of t, or e of t minus l of t. It's one of those two things. And you want to find the maximum value of the actual function. Where do you have to evaluate the function? Where could it occur? The maximum value, just like before. Endpoints. Or this time, the derivative going from positive to negative is either r of t. Wait a minute. Did I say r of t last time going from positive to negative? I'm sorry. I made a mistake, kids. If you want to know where anything, this one I was asking the maximum value of the given rate. It would be at an endpoint, but not when the rate goes from positive to negative. If I want the maximum value of the rate, when the derivative, oh, ouch, goes from positive to negative. Yeah, in fact, the reason I put that in there is because I want you to realize you want to find the max of anything. Find out, check it out at the endpoints and when its derivative changes from negative to positive, or positive to negative for max. Sorry. Is that all right? You want to find where anything has a max. It could be at an endpoint or when the slope changes from positive to negative, when the derivative. Oh, I was like wondering, why am I doing this problem again? Oh, man. Oops. So this one, if I want to know where the function has a max, it would be at an endpoint or where its derivative, r of t, goes from positive to negative. And then you can compare values. Now, I got to draw both situations again. Yes. Yeah. Yeah, when it has its own max. Yeah. When the rate, like you want to know when it's increasing the fastest, that would be when the rate is a maximum. You know, so you would want to find when the bar prime changes from positive to negative. So let's say in this problem, you want to find the maximum value of the function, and it involves one rate, r of t. And we know it could happen at an endpoint or when the rate goes from positive to negative. Let's say that they give us f of a. How are we going to get the value of f of c to compare? Because they've only given us, let's say, the rate in f of a. From a to c of r of t. Same thing. If you want to get f of b, you'll have to take f of a plus the definite integral from a to b of r of t. And if it was a two-rate problem, you do the same thing, but instead of an r of t, you'll have an e of t minus l of t. Should I write that one out? So it could happen at an endpoint or when rate in minus rate out goes from positive to negative. And again, you would just graph it and see where it crosses. And if they've given you f of a, oh, we're going to do one like this. And you want to get f of c, you'll take f of a can add the change by integrating from A to C, rate in minus rate out. Squished. Yeah. Same thing here. What would f of b? How would you get f of b? F of, yes, e of t minus L of t. Ooh, all right, good enough. Okay. Is that too fast? Yeah. All right, so just, these are calculator problems. Usually we like to put the rate in y1, rate out in y2, and rate in minus rate out in y3 if possible. But I thought it'd be interesting today to show you one with a piecewise. I always wanted to show you one like that. And in this little problem here from 2007, they give you, it's actually kind of nice what they give you. This is a calculator problem. It's number 2. The amount of water in a storage tank is modeled by this continuous function, by a continuous function from time 0 to 7. Here's what the interesting part. The rate at which water enters is f of t equals 100 t squared sine rad t gallons per hour. Now that's this one here. They've actually given you the graph, which I think is quite nice. So that's your rate at which it enters. But check out the rate at which the water leaves. The rate at which the water leaves the tank, it's 250 gallons per hour for the first 3 hours, from time 0 to 3. And then from time 3 to 7, the rate out is 2,000. Someone open the faucet up, I don't know. Or the drain, open the drain now, I don't know. So the rate out is a piecewise function. Interesting. Now, I thought that they were so nice because look what they tell us underneath here. The graphs of f and g, so f is the rate in and g is the rate out, intersect at t equals 1.617. Thank you, Mr. College Board person. 1.617. And at t equals 5.076. Now, they didn't give that to us. We'd have to actually graph those lines and get the points of intersection. So, thank you, right? Okay. At time 0, the amount of water in the tank is 5,000 gallons. So, we have a graph of rate in and the piecewise graph of rate out. We know they're 5,000 gallons to start with. Got the idea? All right, let's see what they want to know. How many gallons of water enter the tank from time 0 to time 7? This is one of the few times they ask us to round our answer to the nearest gallon. What would you do to get the total number of gallons that enter from time 0 to time 7? Yes, Kim? Yep, of f of t. And because they've called it this already, that's all you have to write on your paper. But now we got to get the answer. How would we get this answer? See if you can do it right. And try it on your calculator if you have a calculator. Yeah. I can't. I mean, seriously, like you don't have it, yes. Make sure you're in radian mode. You got a number? What did you get? I'm gonna just put it down. 8,000. No, we're rounding to the nearest gallon, so 8,264 gallons. I'm gonna just see if anyone else agrees. You do agree? Oh, that's right. Oh, well, everyone's right. So yeah, that's it. Now, if you had a problem putting that in your calculator, if you enter that function in y1, you could just do math 9, y1, comma x, comma 0, comma 7. Okay, now, this is the good part. For time 0 to 7, find the intervals during which the amount of water in the tank is decreasing. Give a reason. When is the water going to be decreasing? When the rate out is greater than the rate in. So when rate in minus rate out is negative. So then the overall rate is negative. Let's go back to the graph and make a sign chart, shall we? Love the sign chart. So we want to see when rate in minus rate out is negative. So I'm just going to make a little sign chart right under the graph. So this will be my S of t minus G of t. That's the rate in minus rate out. So I'm going to start it here at 0. What's the first number I should mark off on this when it's going to change sign? 1 point, I'm going right to 1.617 since they were kind enough. Now between 0 and 1.617, is rate in minus rate out positive or negative? Negative. Okay, so definitely it's negative on those. Now, what's the next number I should mark off? Go all the way to 5? Yep. Yeah, we got to put it 3. You see how it flip-flops at 3? Oh, that's why we're just... Okay, and then I'll put that other number because that's the next... look at... You see how the rate in is greater than the rate out all the way till you get to 3? But then... Oh, now the rate out is up here. So it's changing. That's going to happen with the piecewise. So between 1.617 and 3, is rate in minus rate out positive or negative? Positive, because rate in is greater than rate out. How about between 3 and 5.076? Negative. And then what about after? I guess it's 7 positive. Okay. Yes. You mean if you had to graph it yourself, then you'd have to graph it yourself. Okay. Yeah. Yeah. I don't know if you've ever graphed piecewise on your calculators. Yes, you do divided by. So like I would have to put in y2. I'd have to put in 250, but then I would hit divided by, and then x is less than 3. You never graphed piecewise? Yeah. You can graph both and no one stops. To get the less than, you got to go to this test menu. It's like a Cadillac you go to. There's a test menu. I kind of think where it was again. Second math. Yeah. Okay, so but now we can answer this question. So as far as kids, the interval where the amount of water is decreasing, we're going to state these intervals where it's negative. Now, you don't have to include where it's 0. When they intersect, it's 0. But I definitely would, I'd include, at 0 in my interval. Like, so I'd say from 0, because it's definitely negative at 0, to the 1.617. I wouldn't include that one because it's 0 there. Again, they're not going to get you if you do that. And then again, now at 3 itself, is it even defined there? No, so I'm definitely not going to do that. And then from 3 to the 5.076, but that's equal there, so if you're going to include anything, just the 0. Bless you, bless you. Okay. Oops. Okay, now here's the fun part. You know these are always worth a lot of points. They say on the time interval from 0 to 7, at what time t is the amount of water the greatest? To the nearest gallon, compute the amount of water at this time. So, where can a max occur? Endpoints. Yeah, when rate in minus rate out changes from positive to negative. And guys, you gotta write that on your paper when you're doing your work for like an absolute max or min. You have to say the max. Yeah, for that justify, you don't want to lose for that. So the maximum can occur at an endpoint or where Rate in minus rate out. Those are called F of t minus G of t. Changes from positive to negative. So we'll get that down as our justification, and now we'll set up our little chart. Now, what times do I have to consider? 0, 3, and 7. See, if we put this, we don't have to check those other critical values. Now, they didn't say what to call the amount of water. I'm just going to say W of t, amount of water at time t. You can call it whatever you want. Oh no, how much water do we have in the tank at time 0? Oh yeah, they told us 5,000. They have to give you something. How are we going to figure out how much water we have at time 3? 5,000 plus, because that's your W at 0. From 0 to 3. Okay, F of t, which I know what that is. You know, like G of t's kind of changes. What should I put in for G of t? The 250, because when the time goes from 0 to 3, G of t is 250. And that we can put in our calculator. Yeah. This what? Yeah, it's just the 1 point. So yeah, if it's just 1 point, you can still that's missing basically. You can still, because you're getting it from 0 up to 3. I know it's 5,000 something. 5,100. You got 26 or 20? Okay. Well, since we only have to round to the nearest gallon, in the end, we'll just do that. Usually we go in 3 places, but this one they said to the nearest gallon. Now here's the kicker. You know how normally we always go back to that starting point? We work off of it. Do I want to do that again? Do I want to go back to time 0? You want to take that and add the change. So you're taking the amount of water at time 3 and adding the change in water from 3 to 7. Now what do I put in for the rate of change of water from 3 to 7? There you go, F of t minus 2,000. Well, I wanted you to see what would happen if it was piecewise. Yeah. I have another one I'll show in a review today after school. The one that's Pablo's. No. Yeah, because what are you going to put in for a rate out? If you say it's 5,000 plus the integral of F of t minus, it's changing, so you have to break it up. Yeah. See, from 3 to 7, we know the rate out is 2,000. So that works. But you can't go all the way from 0 to 7. What would you put in for rate out? It changes. So this one comes out, I know it's less. Do you remember what it was? 4,000? I'm sorry, 4,500? Okay. So to answer the question, they say at what time will the amount of water be the greatest? So we say, it'll be the greatest at t equals 3, and then how much water is in there at that time, and then we can give that amount. So at time t equals 3, the max amount of water will be 5,126 gallons. As far as justify your answer, that work, as well as this explanation, is all we need. Today I'm doing rates, and then I thought I would just focus on rates, and if people were bored of it, I would go to another topic. Okay. I will have all the rates problems that could ever be. You want me to? Yeah. I think that's a good idea. Yeah. In here, in this room. Yeah, Cameron was right. I should have got an idea for numbers. How many people think that they're coming to review today? Oh, I can handle it. I can handle it. Yeah. Yeah. No, it's numbers too.
What exactly? Because, like, when you do an integral or something,
You're adding it up.